if I go into the registry, yeah, that's my Intel Edison registered. I can check the shadow and everything. Also, what I've done here is I've set up a rules, one rule where I'm basically ingesting everything from the topic drone into, well, calling a Lambda function. From that Lambda, I'm ingesting that data into DynamoDB and also into Elasticsearch, which I showed you in the design. Let me just quickly switch back to the actual device itself. So I'm going to switch to my camera here. Hopefully it's visible. So here's the device. As you can see, I've got a drone. It's got Intel Edison on top of this. Let me just show you the cross-sectional view of this. And this Intel Edison has a bunch of SparkFun boards. All these red colored boards are something you can mount on top of each other. You can create these kind of a hardware stack, really, if you will. One of these SparkFun board is powering up Edison, so it's a power block, and one in the middle is where we've got a bunch of sensors. The one we are using is called 9 directions of freedom, which gives us accelerometer, magnetometer, gyroscope, and temperature as well. And then we're going to make some data randomly, just to make it fun. We are creating things such as altitude, the geographic location in terms of the geo coordinates, speed, etc. We're going to generate some data randomly in the code we're going to run on this chip. Okay, so let me move back to my screen. So in terms of the device itself, in fact, this is my SSH session into Edison. It's already sending the payload here. Let me just show you this simple script we're running. So this is a Python script. Now when we run this, I'll show you the code in a minute. But what it's going to do is it will collect some telemetry information from the sensors, and some it's going to create randomly, as I said earlier. And as you can see, this is each payload which is being generated and sent to the IoT platform. It's also doing something in the parallel. We are calling a machine learning service as well in parallel to see whether or not there is a chance of this payload, based on the telemetry information, whether there's a chance of this failing. So let me just actually jump into the code. It'll make probably more sense. So here's the code we are running on the drone. I think the key thing here is, firstly, we are establishing connection with the IoT broker, the IoT platform, MQTT platform, sorry, and then we're getting all this data from the sensors. As I said, accelerometer, magnetometer, and gyroscope. Some of these we are randomly generating. We're getting a timestamp and then creating altitude, speed, etc. I'm calling machine learning. I'll show you machine learning model in a bit, but this is basically a real-time machine learning. So we can use machine learning in 2 ways. We can use batch prediction, or we can call real-time prediction. We are using real-time prediction for this. And I'm checking the value, the prediction value. If it's 1, then we're going to display this message, machine learning identified crash conditions in the drone, etc. And then we're going to create all this payload. We're going to create a JSON object and call the publish function on IoT and dump all this data onto the IoT platform. There's another function here within this code where we are looking for any changes in the state of device shadow, because we'll use Alexa skill later on to update the shadow. And in case it identifies the shadow request as being off, we're going to display this message on the screen on the device, and it will basically pause the program. So we'll test this later on. Okay, so let me come back to the code later. Let's just look at the end product, the visualization. So as I said, we're pushing all this data into DynamoDB, and Elasticsearch. So here's our DynamoDB table. This is where all this data is landing. In terms of the Elasticsearch service, we've got Kibana set up. So, and this is how the visualization is happening. So here we are basically displaying a few things. So firstly, an area chart for temperature, humidity, and pressure. All the values from the gyroscope, magnetometer, and accelerator, the XYZ coordinates are being displayed here. The charts here are getting refreshed every 5 seconds. So this is the lowest, I think, on Kibana you can do, or you can choose different frequencies here. We're also showing line graph on the speed and altitude, how that's changing over a period of time. Now at this point, it's showing every 30 seconds. And this bottom chart is where it's showing the machine learning failures it's identifying, because with each payload, as I showed you in the code, we are checking whether or not it's likely to be a failure. So just a visual representation where in the timeline machine learning is predicting failures within in the payloads. So and we can zoom in and zoom out of this chart. Okay, so let me quickly show you the machine learning setup here. So I've got my model here, drone telemetry. If I go inside this, you can see. So this is as I said earlier, this is a binary prediction model. And the data that we have supplied to this machine learning model looks something like this. So I basically randomly generated this data with a bit of telemetry, and I've got a target field which we are actually predicting in machine learning. So you'll notice some of these records I've put 1, and 1 means which is that's how I've trained my model to say when the combination of these fields is this. That's what I use to basically train this model. And that's what it's going to use when I throw new parameters, new payload. It'll use this training to identify whether or not it's a failure. And with machine learning, it gives us a prediction, and it also gives us a prediction score as to how confident it is with that prediction. In fact, that's what we are also displaying on the console. With each payload, we are checking machine learning prediction and machine learning score, the prediction score as well, which we can use to make any further decisions, like how to treat that value. Okay, so we've seen the visualization, we've seen the machine learning, we've seen the DynamoDB, IoT. Now going back to our design, I wanted to show you a couple of Alexa skills as well. Now for that, I'll just move back to my video. So hopefully you can see that as well. Let's just turn our Alexa dot on. So Alexa, ask drone for its current location.
Hello Niraj, the drone 3 is currently flying over the pipeline in Zone A, at an altitude of 485 meters. Its current speed is 11 kilometers per hour.
Okay, that's great. So let me just show you the code, the Alexa skill, which is running in the background. The Alexa skill is fairly simple. Let me just get to the right code. So in this Alexa skill, we are basically setting up a DynamoDB object, and like you would use call a DynamoDB APIs otherwise. So the key thing here is, if we look at the speech output here, this is the script which Alexa skill is going to throw back, and I'm pulling these variables for altitude and speed from DynamoDB, which I'm pre-processing before sending this speech output back. And if you're familiar with Alexa, this code is running as a Lambda, and we have to configure this Lambda ARN on the Amazon development portal, where you configure your skill with all the other parameters like the intention and the invocation, etc. Let me quickly see if I can show you the setup as well. Okay, so We go into Alexa. Very slow for some reason. And then Alexa Skills Kit. Here you can see all the skills I've built. I think let me just jump into this one. So here, what you can see is this is how you configure Alexa skills in Portal. You have to specify your interaction model, your intents, your utterances, like how you are going to communicate with the skill. In the configuration is where you specify your Lambda ARN, which is the code I showed you earlier. So fairly simple setup. So if we go back to another skill that I've built on Alexa. So previous skill was how you can get value out of database or how you can query any other service. I've built another skill, and here I'm going to control the device. So the skill will actually update the IoT shadow. We're basically going to turn the engine off in this case. It's what we're going to update in the shadow. As you can see here, this is where we are updating the IoT shadow, and the skill itself will then simply call out the speech that it's initiating the drone landing process. But once we update the shadow in the skill, what's going to happen is back onto our code in the on the device is going to recognize the state has changed, and it will basically halt the program. So let's just test this. So we are back on our console. This is the SSH session going on with the device. And I'm going to go back into the camera so I can show you both of these screens together. Okay, I'm gonna switch my Alexa back on. Okay. Alexa, ask drone controller for emergency landing. And here you go.
Okay, I'm now initiating the emergency drone landing process. The drone will land at its closest landing zone in approximately 5 minutes.
Fantastic. And as you can see, the program is halted as well. It recognized the state, the shadow of IoT thing has been changed. And this is just a simple way to demonstrate how you can control devices, not just with Alexa, but it could be mobile app, it could be any other application through shadows. So yeah, hopefully that was helpful.